It asks what the scale factor is. Notice, this one is 3, this one is 12. So how many times bigger is it? It's got to be 4 times bigger, right? 3 times 4 is 12. So scale factor is 4. What's the missing side? You could either say, well, then 8 times 4 is 32, or you could cross multiply. Little is to big as little is to big. 3 is to 12 as 8 is to n. And I cross multiply. 3n is 96, divided out 32. Either way, I get the correct answer. Any questions on number 8? Okay, let's take a look now at number 9. The sides of the triangle are 6, 7, and 8. Find the perimeter of a similar triangle whose longest side is 40. Little is to big is little one. It says this is the longest side of the big one. So 8 is to 40. And now this perimeter, I added them up. 8 and 7 are 15, and 6 is 21. And I don't know how big the other perimeter is, so I call it n. This is one where it's easier not to cross multiply. 8 times what is 40? 8 times 5. So 21 times 5 is 105. Okay. Next one. Pythagorean theorem. It's a right triangle. You know what I didn't do? I didn't draw the right angle and the hypotenuse is across from it. But 17 is the hypotenuse. So leg squared plus leg squared is hypotenuse squared. And I get n squared plus 12 squared is equal to 17 squared. And here's the mathematics of it, or the arithmetic of it. 12 squared is 144, 17 squared is 289. I subtract 144, and I get n squared is 145, and that's an irrational number. There is no whole number that is the square root of 145. Yes?
Do you have any tissues?
Now, I'll give you a paper towel. Okay, so let's go to the next one, which is right here. What we wanted to do, I didn't do the one with graphing the lines. What I did was I took the point negative 2, 5, and I reflected it over the x-axis and then the y-axis. Everybody put your hands up. Which way does the y-axis go? Up and down, vertical. Show me the x-axis. Very good. Okay, so this then is the x-axis because it's horizontal. So if I reflect over it, what 2 words do you always remember with a reflection? Kind of repeat. So it's 5 and then another 5. I get negative 2, negative 5. And then the y-axis is vertical, 2, 2. So I get 2 comma 5. Okay? To me, that kind of question should be very comfortable. We should be like, I can nail that every time. All right, now, Talia asked about a dilation the other day. What is the image of the point negative 2, 5 after dilating by a scale factor of 4? To dilate means to get bigger or smaller. So if I'm going to dilate by a scale factor of 4, that means I'm going to multiply by 4. So negative 2 times 4 is negative 8, and 5 times 4 is 20. So the answer is negative 820. What about by a factor of negative 5? Negative 2 times negative 5 is 10. 5 times negative 5 is negative 25. And this is what we did before about the reflections. Any questions on those? Okay. So that's a pretty good representation of what it is we've done so far with our work on transformation geometry. Now, we're supposed to end at 12:19 today, and I don't know if I'm going to have time to go over the do it, but we just did a bunch of similar questions, so I'm not going to worry too much about that. I want to skip forward to today's lesson. And today, we're going to talk about what we call rotations. And here's our swirl moment of the day. What does a rotation mean? Talia.
Moving in my same way.
Your finger is doing a great job of explaining it, and your mouth is not. Well, give me 2 words. I can think of 2 words that describe a rotation. Lizzie? What's a word that describes it or means what rotation means? Turn or spin. Turning and spinning is a rotation. What are some things in the world? Turn to the person next to you. Say rotate means to turn or spin. Now, think of something that rotates or spins in real life. whole bunch of people shot stuff out. The last class was like
The
silent.
microwave?
The thing in the microwave. Leah, what did you say?
I didn't say
Yarlene?
the clock.
Clock. Good. Clock's a great one because we're going to use that. Lizzie?
Earth.
The Earth. You know, that's what the other class said. I hadn't even thought about that one, but that's a rocking answer. Anything else that spins or rotates? Yep. A wheel, yeah, on a bicycle or in a car, right? Steering wheel. Cars would be pretty dangerous if those steering wheels didn't rotate. Okay, Middledorf, I think you had something?
That's it,
Same thing? Okay, good. So here are some pictures of some rotations. And the first thing I want you to notice is that the rotation, see how it says 90 degrees? That's a positive 90 degrees. And it goes counterclockwise. Everybody look at the clock. See which way the red hand is turning? Because you can see that one moving. All right? That is the second hand, and that's the normal direction a clock goes in, if you will, kind of like from left toward right at this stage of the clock.
It's clockwise.
Right, it is clockwise. When we do a rotation, unless told otherwise, we go counterclockwise. Now, the word counter means against, okay? In wrestling, we do these things called counters. If a guy tries to give you a half Nelson, you counter the half Nelson. If he tries to hit you with a head and side cradle, you step up windmill, and you counter the head and the side cradle. If he tries for a far side cradle, you free your arm, you hip in, make sure you don't go down to your shoulder or you're in trouble, and you get out of a far side cradle. We need to be able to recognize rotations outside of coordinates. Just see them. Can everybody see how this triangle here is spinning? It's turning, it's rotating. Same thing here.
It's going counterclockwise.
Right, same thing here. And they are, very good, they are going counterclockwise. Can you scooch back a little? Now, it shows you here that a rotation is a turn. Clockwise, here's your clockwise notation here. Here is your counterclockwise, see counterclockwise, notation going back here. So now they take the letter P, which doesn't have any symmetry, and they start spinning it or rotating it. Now, first off, is this a clockwise or counterclockwise rotation? Clockwise. And they would say that in the directions. They'll use the word clockwise. They could also say it's a negative rotation. Clockwise is always negative. Counterclockwise is positive. So the P starts here, and if I spin 90 degrees this way, the loop of the P, if you will, ends up on the bottom. It's also called a quarter turn. Here's a circle. If I go all the way around the circle, that's a whole turn. But that guy just went a quarter of a turn. A quarter of a turn is 90 degrees. By the way, the reason there's 360 degrees in a circle, the first people who began to realize, they knew way back when that the earth revolved around the sun. Don't let them think you, let people tell you they thought otherwise. Intelligent people knew thousands of years ago that the earth rotated around the sun. But where they made a mistake, they didn't think it took 365 days. They thought it took 360 days. So for them, each day was a degree, and they didn't realize it was an elliptical orbit. They thought it was a circular orbit. Now, if I turn another 90 degrees, that would be as if I turned 180 degrees. And now, where it was on the bottom, I turn another 90, now it's facing to the left. Or if I just look at this as a 180 degree turn, it was here. If I spin it 180 degrees, it's got to go there. Everybody take your paper. Look at this question, this P right here. Now I want you to turn your paper over 180 degrees. Just spin it 180 degrees. That means turn it upside down. Spin that paper. Now do you see how your P looks like this?
Like a regular P.
Like a D, right? Starts like this. If you spin your paper 180 degrees, it ends like this. And lastly, we have this one here. If I go another 90 degrees, just take your paper, turn it another 90 degrees, and you'll see that it goes there, okay? Actually, I'm sorry, Cheyenne, I should have said you turn the other way, because this is counterclockwise. That's what you did. All right, so those are pictures of rotations. And now what we want to do, one last picture of a rotation. Triangle PQR, I rotate, this is clockwise 90 degrees, P prime, Q prime, R prime. We've become used to, I hope by now, this prime notation. Now, when it comes to rotating, it is so easy for you to do. I want to emphasize two things I just said. So easy and for you. It is not easy for me. I'll show you how easy it is for you. Everybody on your paper, go to the point 3-7 and make a mark. Everybody there? Now, all I want you to do, now, this doesn't say clockwise or counterclockwise, so we assume counterclockwise. All you're gonna do is take your paper, okay, everybody hold your paper up, and we're gonna turn it 90 degrees counterclockwise. Now, if you put new coordinates on your graph, what would the coordinates of that point be? Just look at it right there. What would the coordinates of that point be? -7, comma, +3. Right? Isn't it up above the line? Right? So it would be -7, comma, 3. And that's the correct answer. Now, I said before, it's really easy. Is that really easy? Just turn your paper, look at what the coordinates would be. I also said for you, I would have to spin this board. That's not happening. There's a whole bunch of bolts back there. So the board's not spinning, okay? Yeah, you gotta tilt it the other way though. There you go. Okay. Now, what we want you to do is the same thing to the point -2,4. But so you don't get confused on your paper, mark -2,4 with an X. Now, spin your paper 90 degrees. And what would the new coordinates of that point be? -4, -2. Good. Now, these are all how many degree rotations? 90-degree rotations. Very good. And they are what? Clockwise or counterclockwise? Counterclockwise. If we don't tell you which direction to go, you always go counterclockwise. If it says +90, you go counterclockwise. Now let's mark -1, -5, and let's do this one with a Y. -1, 1, 2, 3, 4, 5.
Already got it.
Okay? Now, spin it 90 degrees again, counterclockwise. What do we get now? I don't think you get -5, -1. +5, -1. Right? Okay. Now, the next section says, let's do the same points by 180 degrees. What do you think you're going to do to your paper this time? Turn 180, which is basically turn it upside down. It's 90 and then another 90. So turn your paper 180 degrees. Tell me what we get for 3-7. -7, -3. I think, right?
No, -3.
Oh, it's -3, -7? Everybody agree with that? Right? Do we get -3, -7? Okay, good. Now let's take the point -2,4. All right. I think you get the idea. 270 is 3 turns. Okay? All right. Hasta la vista. Vaya con Dios. Tulu tata. Arrivederci. I think we do another day of rotations on
I think I'm getting sick.
Monday, so I think we're going to be all right.
I actually think that I'm getting sick because my nose is stuffy and my glands are swollen, so.
Or it's a cold, because